Good evening, everyone. So, welcome to Career Launcher. My name is Naveen, and today we will be looking at set theory, part one, and we'll be looking at a few of the question types. Okay, so let's begin. But before that, I would like you guys to, there is an announcement to be made. So MBA boot camp is going to be it's going to be conducted on 26th and 27th of this coming month, as in this month, this coming weekend. This will be interactive session by IM alumni people, proven techniques by CAT top mentors. We'll be solving questions smartly, not formulas all the time. And we will also practice new CAT level questions. Okay, so let's begin with our first set of the day. So what I will do is I'll give you 3, 4, 5 minutes to go through the language, try to attempt it. All these sets are previous year questions from one of the exams or the other. So try, give this a try. Let me know once you are done. So I'll wait for another couple of minutes. In the meantime, if you are done, great, let me know. If not, we will start the discussion. So you have to be smart about, which statement to begin from, how to manipulate the sequence of statements. They are very, very important. Okay. So in case you guys have solved it, these are the questions. So based on the information given, the minimum number of volunteers involved in both FR and TR projects, but not in the ER project. Which of the following additional information would enable to find the exact number of volunteers? So if you read the language of the questions, it tells you that you may not necessarily be able to figure out the values at every region, right? So if you pay attention, there are actually 3 projects. So it's a 3-set Venn diagram that is required to be solved, right? So we will use 3 sets. So the first set is going to be, let's say, the TR project. The next one is going to be FR, and the next one is going to be ER. We are told that it has currently 37 volunteers. So the overall value is 37. We are also told that each volunteer working with the different projects has to be involved in at least one relief work project. That tells us that outside value is 0. Each of the volunteers, they will lie inside at least one of the circles or one of the sets, right? Now, there are 5 bullet points. First one says maximum number of volunteers are involved in FR project. So if I write something over there, it will not help me determine anything. Among them, the number of volunteers involved in FR project alone is equal to the volunteers having additional involvement in the AR project. So we won't be able to put anything over there again. The number of volunteers involved in the ER project alone is double the number of volunteers involved in all the 3 projects. We do not know the values, so we won't be able to put them. 17 volunteers are involved in the TR project. Now, this is something which is kind of concrete. So that is 17. Next, the number of volunteers involved in the TR project alone, so this one, is 1 less than the number of volunteers involved in ER project alone. We do not know ER project alone, so this will again not help. 10 volunteers involved in the TR project are also involved in at least one more project. So as per this last bullet point, it tells us this is 10. If this is 10, so this is going to be 7, because the overall value of TR is 17, right? Now, if this is 7, then the second last bullet point tells us the number of volunteers involved in the TR project alone, which is 7. This is 1 less than the number of volunteers involved in ER project alone. So this is supposed to be 8. Now, the moment we get ER alone as 8, we can go back to the second bullet point. The number of volunteers involved in the ER project alone, which is 8, is double the number of volunteers involved in all the 3 projects. So if this is 8, all the 3 is supposed to be 4, right? So we are done with this bullet point as well. Now, if you know, the sum of all these three regions for TR was 10, right? So what I'm going to do is I'm going to say that, let's say this one is A. So since this was supposed to be 10, this is going to be 6 minus A. So that the overall sum is 17, right? Let's read the first bullet point now. Among the people who are in FR project, the number of volunteers involved in FR project alone is equal to the volunteers having additional project in ER. So additional project in ER is, let's call this as, excuse me, B. So it is given that if this is B, so FR and additional project, right? Additional involvement in the ER project is 4 plus B. So only FR is going to be 4 plus B. Now, if we calculate the overall value of FR, this is going to be 8 plus 2B plus A. And if you look at ER, this is going to be 18 plus B minus A. Now, there is only one equation that we haven't used, which is sum of the values at each of these 8 regions should be equal to 37. So let's use that. So what we are going to do now is we will look at the TR project. This overall value is already 17. 17 plus 8 plus 4, 17 plus 12, that's 29. So we'll have 29 plus 2B is equal to 37. So this will result in B going to be equal to 4, right? So we get the value of B as 4. So this becomes 4 and this becomes 8. That means the overall value of FR and overall value of ER now reduces to a simpler expression. So this is going to be 8 plus 4 plus 4, which is 16 plus A, while that for ER is going to give us 8, 16, 22 minus A, right? Now we are told that FR is the largest. That means 16 plus A should be greater than 22 minus A. Also, 16 plus A should be greater than 17. So that means A should be greater than, from here, it should be greater than 1, right? So A is going to be minimum 2 that we can take. And from here, we will be getting 2A is going to be greater than 22 minus 16, which is going to be 6, or A is going to be greater than 3. Now, if we look at this, if A is going to be greater than 3 and A is going to be greater than 1, so if we club them, can we say A is greater than 3? So A can take the values 4 greater than 3 would mean 4, 5, 6. It can't take 7 and above. Do you know why? Because 6 minus A has to be a whole number. If 6 minus A has to be a whole number, the largest value that A can take is 6. So basically, we are going to have these 3 possibilities when A can be 4 or 5 or 6. We won't be able to figure out anything further, right? Now, let's look at the questions. Based on the information given, the minimum number of volunteers involved in both FR and TR projects, but not in the ER project. Both FR and TR is going to be this region, but not in the ER project is going to be just A. So what is the minimum number of volunteers we can have for this place? So we can see that A minimum is going to be 4. So it's going to be option number C. Next question. Which of the following additional information would enable to find the exact number of volunteers involved in various projects? In other words, which out of these 4 statements will help us figure out the value of A uniquely? First option, 20 volunteers are involved in FR. So if I say 16 plus A is 20, will that help us find out? Yes. That's it. You don't have to further check it. Third, after some time, the volunteers who were involved in all the 3 projects were asked to withdraw from one project. So basically, we are told that out of these 4, they were asked to withdraw from one of the 4 projects. So consider this. These are the 4 people who are involved in, each one of them is involved in TR, FR, and ER, TR, FR, and ER, and so on, right? All 4. Now, somebody who withdraws from TR will go to FR and ER only. And somebody who withdraws from FR will go to TR and ER only. Somebody who withdraws from ER will go to uh, TR and FR only. So depending upon out of these four people, which person withdraws from where, they have got a very specific place to go. So as a result, one of the volunteers opted out of TR project. So if one volunteer opts out of TR project, so that volunteer will come here, and instead of 4, now we are going to have 3 here, right? Okay. And one opted out of ER project. So out of these 3 people, if one opted out of ER project, so that means that person is going to go here, and then we will have only 2 people left. While the remaining ones involved in all the 3 projects opted out of FR. So all these 2 people, they opted out of FR, so they will move to only TR and ER. So that means there is nobody here. Now, which of the following statements then necessarily follows? First, the lowest number of volunteers is now in TR project. Let's look at TR project, the total number of volunteers. Initially, there used to be 17. Now, there is a decrease of 4 from there, but an increase of 3. In other words, there is a decrease of 1 overall. So for TR, we can say that there are going to be now 16 people. If you look at FR used to be 16, out of which 2 people left, 16 plus A, sorry, out of which 2 people left. If 2 people leave, so we will have 14 plus A. And if you look at ER used to have total 22 people, out of which 1 person left. So we will be having 21 minus A. Now, if A is 4, we can have 18 and 17 people. If A is going to be 5, we will be having 19 and 16 people. If A is going to be 6, we will be having ER lesser. So it's not necessary that TR is going to be the lowest number of people, right? So the lowest number of people is in TR project. This is going to be false. Next, more volunteers are now in FR project as compared to ER project. So we can see that number of volunteers in FR project is more than ER project. This is very much true because ER will keep on decreasing, right? So this statement is true. Fine. Shouldn't check further. If you're confident enough that whatever calculation you're doing, whatever things you are checking, all of these are correct, as in you're not making any mistake there. Next, after the withdrawal of volunteers as indicated in previous question, so it's not 89, it's 3. Some new volunteers joined the NGO. So we will bring in more people now. Each one of them was allotted only one project in a manner, thus that the number of volunteers working in one project alone for the 3 projects became identical. So if they are going to be identical, that means only one person comes here, right? So that it's 8, 8, and 8. At that point, it was also found that the number of volunteers involved in FR and ER was same. So FR and ER, they are going to be same. So that will happen because now we have 17 people in TR and we also need 17 people in ER. That will happen when A is 4, right? 21 minus 4 is 17. And number of volunteers involved in FR and ER projects. So FR and ER is what they are saying, right? FR and ER. So it's not FR and or ER, it's FR and ER. So let's look at FR and ER. So FR and ER is going to be 5. And same as the number of volunteers involved in TR and ER projects. So TR and ER is going to be 8 minus A, and it's also given as 5, right? Which of the projects now has the highest number of volunteers? Now 8 minus A is going to be 5. That means A is going to be 3. But we know that A cannot be 3. The minimum value of A is going to be 4. So that means nobody can determine it. inadequate data, right? Okay. Now let's move over to the next set. Again, give it a try. This set may look difficult or time consuming, but it's not. Initially, you will have to spend some time in order to understand how should you represent it. Should you draw a Venn diagram, or should you do chocolate distribution, or should you write down equations? So I'll give you guys 4 5 minutes again. Give it a try. Okay, so you can see that there are four people here: Amir, Salman, Shah Rukh, and Akshay. So basically, it's a four-set Venn diagram. Okay. So if you look at the questions, every question has a definite option, and those are based on numbers or percentage. So we need to figure out how many students like only Akshay or only Amir or only Salman or a combo of two, right? So let's start. In a school, students like four different actors: Amir, Shah Rukh, Salman, and Akshay. 17% of the students in the school don't like any of the four actors. So if I say total number of kids in the school is T, so 17% of T, they stay outside, right? Number of students liking these four actors are these many. So for Amir, we have got 385 kids who like them. Then Shah Rukh has 335. For Salman, again, we have 335. And for Akshay, we have got 375. The number of students liking exactly two actors for any combination of two actors is 60. So combination of two actors, or those regions which are part of only two sets, are these six regions, right? So as per the question, the value at each of these six regions is 60. So this is 60, 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 and this is 60. Then we are told there are 80 students who like all the four actors. So this is the central most region, right? This is the central region, but there is no such student who likes exactly three out of these four actors. So north, south, east, and west of the exactly four wala region is exactly three. So these are going to be 0. So we can figure out the values everywhere. So if you look at Amir, this is 60, 60, 60, 180 plus 80, which is 260. 180 plus 80 is 260. Similarly for Shah Rukh, it is 60, 60, 60, 180, 180 plus 80 is 260. So no matter whichever person I take, it's 260 already. If we need 385, so that's an extra 125 that is required. If we look at Shah Rukh, overall is 335, out of which 260 already exists. So this is 75. Same 335 is here, so this is going to be 75. And this is 375, which is 10 less than Amir's. So this is going to be 115. Now, if we add the values at each of these 15 regions, so Amir is already 385, right? So I'm saying this is basically 385 because it's written outside. Then we have 75, 75, that is another 150. Then we have 60, 60, 60, which is 180. And then we have another 115. So 385 plus 115, this is going to be 500. And 150 plus 180, this is going to be 330. So if we add them, this is 830. So if 17% of the students, they lie outside the four sets. So that means 83% of total lie here. So that means T is going to be total 1000. So there are total 1000 people or 1000 students, out of which 170, they do not like any of the given four actors. And the remaining 830, they like at least one of these four actors. That's it. So you can see that the only time consuming part was to draw the four-set Venn diagram. Apart after that, everything was simple addition and subtraction. Let's look at the questions now. How many students do not like any of these four actors? 170, right? The value outside at the place of none of the sets. Approximately what percentage of the students liking Shah Rukh Khan also like at least one other actor? So if you look at Shah Rukh Khan, this is 325, out of which 75, they do not like, they like only Shah Rukh Khan. So 60, 60, 60, that is 180 plus 80. Can we say these are 260 students? Out of students who like Shah Rukh Khan, it's 335. So what percentage is this going to be? So basically, if you look at the options, we have to be very, very much precise. In such kind of questions, we generally prefer using calculators. So they both are divisible by 5. So this is going to give us 52 and this is going to give us 67. Now 52 by 67, if I need to solve, there are two ways to do this. I can take 5200 and divide it by 67 if you are good with its table, or do a 70% of 67 and then calculate 5% and so on. So right now, if I look at the options, every option says, somewhere around 77, 78%. So what I will do is I will directly calculate 80% of 67. Now, 80% of 67 is going to be, excuse me, 10% of 67, which is 6.7 into 8, right? So this is going to be 8 into 6, 48, plus 7 into 8, 56. So this is going to give us 48 plus 5, which is 53.6. So I'm reducing. Rather than calculating from 70 to 77, I think it's better if I go from 80 to 77. Now, if I subtract, let's say, 2% of 67 to see whether we reach at 78 or should we decrease it further. So 1% of 67 is going to be 0.67. So 2% is going to be 1.34. So if I subtract it, I will be getting 78% of 67. This is going to give us 53 minus 1, which is 52.26. Our target is to reach 52. So we can very clearly see that it's not 78, it's less than 78. Now, let's calculate 0.1% of 67. Now, 1% of 67 was 0.67. So 0.1% will be 0.067. So if we subtract that, we will see that we are going to get closer to 52. So basically the question is 0.067 into what will result in 0.26, because I need to get rid of that, right? So if I multiply this by 3, 0.67 into 3, what I will have is 6 into 3, 18. So this is going to be somewhere around 0.2. So basically, if I subtract 0.3%, as in if I'm at 77.7%, this will not be good enough, right? So answer is not 77.8. Now, what if I multiply this by 4? Where do I reach? So double of 67 is going to be 0.268. So this is going to be approximately 0.26. So that means I have to subtract 0.4%. 0.4% from 78% will give me 77.6%. So option A is our answer. So if you have a calculator, great. If you do not have, you will have to do this calculation. Okay, next. If all the students in the school, including those who do not like any actor, start liking at least one actor, which she is not liking at the present, then what could be the least number of students liking all the 4 actors? So basically the question is, if we have these 0 people, if we have these 170 people, let's start from here, they do not like any of the actors. Suppose if they start liking one actor that they do not like so far, right? So they may go to, if they like only Amir or only Shah Rukh or only Salman or only Akshay. The people who like exactly one actor, if they start liking one more actor, so these people may go to either one of these 60s. Now, these people who are at 60, whose count is 60, they like exactly 2 actors. If they start liking one more actor, they will now increase the value of people who like exactly 3 actors. And since there is no one who likes exactly 3 actors, so that means if they start liking any actor, they will increase the value of these 80 people. But since we do not have any such, so those 80 will stay 80, right? So start liking, at least one actor. So we will keep that as 80. We will not try to increase that. Okay. What is the number of students liking exactly one actor? So for this, Obviously, we are supposed to add 125 plus 75, which is 200. 115 plus 75, which is 190. 200 plus 190 is 390. And option C becomes our answer. Right? Okay. So, again, I would like to reiterate, MBA Bootcamp 2024 is going to be conducted on coming weekend, that is 26th and 27th of October, this coming Saturday and Sunday, where we'll be discussing the most probable questions that will come in CAT, great techniques and smart approaches to solving questions. And this will be conducted by IIM alumni. Okay, make sure that you guys check it out. Make sure that you go to the link which is available in the description below. Now, question time. Do you guys have any queries? Anything that you guys would like to ask regarding preparation and anything? Anyone? No? So, thank you. Thank you, everyone. I'll see you again very soon with next session on set theory. Until then, take care. Bye-bye.